So I want to do a short video as a note to self. When I make these Princeton Reverb clones, I keep telling myself that I'm not going to do it again, and then I end up doing it again, and I wish I had a little more notes. I'm not good at reading schematics. So I make these on Doug Hoffman's layout. I've printed out here. And the layout itself is ingenious, but the spatial, the spacing leaves a lot to be desired, because the tubes are oriented totally wrong, and none of this corresponds in space to where it is in a chassis. So I sort of take some notes here on some things that I've done and what things look like when it's finished. This is about to get bench tested. So Hoffman's layout doesn't include any of the, at least this one doesn't include any of the rectifier wiring. There is another page, I think, that might. But this, I use these silicon diodes as backups in case the power tube fails. So the connection is actually at this pin, which is pin, gosh, I can't remember. Looks like 4, yeah, 4. And you make the connection through the diode. Same here, connections at 6, make it at 5 through the diode. Also, your bias range is here. Bias tap is here, but the layout doesn't show the supply coming over from the rectifier, which also joins up at pin, let's see, 4, let's see, 1, can't see anymore. Yeah, 1, 2, 3. Sorry, you go 3 to 4, and then 5 to 6. So I've got power wiring. This is a power cord ground. Hot goes to the end of the fuse. Then there's a bridge over to the switch. You have your primaries here. This is your neutral connection here. And then another one goes over to the other side of the switch. And then you have your can capacitor. This thing goes counterclockwise in terms of order. And I've marked these, so like yellow goes here, green here, white here, and clear here. I guess once you're done with the initial 40 microfarad section, which is here, it really doesn't matter because these are all 20 sections. This is a ground lug, so here's your high voltage center tap and grounded. Heater wiring in the traditional way, over to, this is V5 and V6, the power tubes. Looks like, I wonder if I've actually, no, that's right, 1.5K here. So this is one of your grids, screen grid, I think. And here, so you make the connection through pin 6, which is empty on a 6V6 on an octal socket. And your pins 8 and 1 are tied together. And one thing that I really like is this, is Hoffman puts these 1 ohm bias resistors on the board right here. And those just go to ground. Each of those goes to ground at pin 1. Here are your plates. So you always leave enough length to where these can be switched if necessary due to negative feedback, which way it runs. Here are the inputs. Used really big gauge wire here just because it was coming out of the output transformer. Don't know why. I add a 470K resistor here before the phase inverter, pin 7. to reduce blocking distortion at high volumes. Here's your negative feedback connection that goes to the board here. This is where your reverb transformer comes into the board. Here's the reverb wiring and the tremolo wiring. So this will probably be, this is reverb, ground. There's a resistor. Nope, sorry, that's not ground, that's tip. The resistor, this is like a 220K, I guess. 2 red lines, goes to, I ground it here. And then that goes to V3 right here. That looks like pin 2, maybe. Here's your tremolo switch that comes to the board here. One of the things that I do is I change this resistor. I believe in Hoffman's layout it's a 1 meg. Let me check. Yeah, and that looks to me like a 470, yellow, purple, yellow. Helps with the tremolo. And I also use these ceramic disc capacitors. Hoffman's layout, as is typical of Fender, I believe, has 0.01, 0.01, 0.022. I use 0.01, 0.022, 0.022. Again, help with the tremolo effect. And these ceramic disc capacitors are supposed to be a little bit unstable or something in a way that may be cool for the tremolo. We'll see. I mean, I've used them before and it always sounds great, so why change it? This build, as you'll see, I've used carbon composition resistors throughout. I've used metal film before. Most of these are carbon comp, except that's a metal oxide because that's a big 3 watt or 2, maybe it's a 2 watt resistor. The capacitors look like they're all Illinois capacitors, though Tube Depot labels these as Zycon, which I don't think they are. And these, what are these? Mylar film, not film. I think there's some Mylar sort. Anyway, so polarity here is switched, so the notch goes this direction, this way, whereas as you see on the rest of the capacitors, the notch goes toward the tubes that way, that way, that way. Inputs on this is always a bugbear because everything's jammed up in here. I used a shielded wire to V1, but not from. I did it originally and then ended up tearing it out and just used this regular wire under the board to there. But I'm hoping it works well. And I'm optimistic because I've done several of these. Oh, this is another thing that I really like to do. You'll see that I've made a bus wire here, and I do it on nylon standoffs just so it doesn't have conductivity to the chassis, but I also like it that it doesn't mount on the casing of the pots, and that way if you ever needed to change a pot, it's a lot easier to get those things out and you're not ruining this independent bus wire. So I don't know, maybe that does some good. Anyway, I'm hoping this works as well as I think it will and sounds as good as I think it'll sound. Finish it up here in January 2024. It was begun in 2020 during COVID and was set aside and not finished. And these things is pretty cool. These are all classic tone resistors, excuse me, transformers. So classic tone output transformer, classic tone power transformer, classic tone reverb transformer. Before they went out of business, I was still able to get these, and I think that's pretty cool because they are unobtainium now, completely. So this is like kind of a new old stock kind of situation, which is kind of fun. So more soon. If there's any big trouble or anything, I'll try to report back on another video, just as note to self. Oh, one more thing. I used these, this heater wiring. I got this wire from Tube Depot. I think this is this aerospace grade Tefzel wire or something. So I used 18 gauge here, and then here I went to 22. I did not like this 22 stuff. It's too fine, and the the insulation melts back from the wire pretty quickly. This stuff, the insulation seems much more durable, the 18 gauge. Once you get to the preamps, you don't really have to use 18 gauge. You could use something like 22 like this. But I'm not so sure I really like this stuff. It was a little too fine. But this 18 gauge stuff seems okay. It doesn't twist all that well, but I like to use the green and the white. At least once I get to here. I did it here as well this time. But at least once I get to here, just to show to keep things in phase. So green's always connected here. This is 4 and 5 on the preamp. This is 9, 4 and 5, 9, 4 and 5, 9. Over here, it's the heaters are 6v6s are pins. What's that? I think it's 7 and 2. Anyway, this is for adding a variable resistor. Here, this is a fixed mid-range resistor, 6.8K if I remember correctly, on the base pot. And you can use this as a mid-range control, but I'm going to bench test this thing first, because you have to fly it all the way over the board and make the connection here and use your mid-range control back here if you want to do that. So we'll see if I want to do that or not. But that's what I know, and I think I took care of everything on the layout that's different. Oh, that reminds me, one more thing. So this shows a single layout, and it shows you a 1 meg resistor here, as you'd expect, but then a 33K resistor just prior to pin 2. This is going to be, if you use 2 inputs, it's just basically do it just like the Fender layout does it. Here is an upgraded do-it-yourself layout program, and I need this kind of thing because I don't read those Fender schematics well at all. So you just do it like these inputs show here on the Princeton Reverb. Anyway, so notes to self for next time. I keep saying there's not going to be one, but there always is. So if there is, then maybe this will help me out.